So, what if the same AI that can spot your face in a photo could also be used to protect the food supply for literally billions of people? Well, that's exactly what we're diving into today. This incredible crossover between deep learning and farming. And it all revolves around one of the most important crops on the entire planet. But to really get a handle on just how big of a deal this is, let me start with a question for you. Just think about it for a second. What's the one single plant that half the world relies on to eat every single day? You got it. It's rice. It is the absolute cornerstone of global food security. But this humble little grain is facing a massive and constant threat. Yeah, things like brown spot, blast, bacterial leaf blight. These diseases can absolutely tear through rice crops. We're talking devastating losses in yield, which means huge economic hits for farmers and even for entire countries. So you can see, protecting this crop isn't just a farming problem, it's a global one. So how have we been dealing with this? Well, the traditional way is a tough gig. You have experts literally walking through fields, looking at leaves one by one. It's super slow, takes a ton of work, and, people make mistakes. But this new automated method using AI, it's a total game changer. It's fast, you can scale it up, and it's way more accurate. Okay, so clearly we need a better, smarter way to do this. How can we use technology to build a stronger defense for the world's rice? Well, the answer lies in a very specific kind of artificial intelligence. We are talking about deep learning. And here's the really cool part. Instead of trying to write a bunch of code to tell a computer what a sick leaf looks like, you just show it thousands and thousands of pictures. You let it learn the patterns on its own, kind of like how we learn to recognize faces without a rulebook. Now, within deep learning, researchers have this whole toolkit of different ways to tackle the problem. They can build a brand new model from the ground up or combine a few models to get a better result. But honestly, one of the most powerful and efficient techniques, and the one we're going to focus on, is something called transfer learning. The best way to think about transfer learning is like this. Imagine you want an expert art historian to be able to spot forgeries. You wouldn't start by teaching them what paint is, right? They already have all this general knowledge about art. You just give them a new, very specific problem to solve. That's it. You take an AI that's already a pro at understanding images in general, and you give it a new specialty, in this case, spotting sick rice plants. So what does that actually look like in practice? Well, it's pretty straightforward. First, you start with one of these super powerful models that's already been trained on millions of general photos. Then you just fine-tune it a little, showing it a much smaller, specialized set of images, pictures of diseased rice leaves. And bam, you've got a highly accurate specialist model in a fraction of the time and cost. And this quote from the research really hits the nail on the head. See, the old way required human experts to manually tell the computer what to look for. Look for this shape of spot, or this color lesion. But deep learning just figures out those critical patterns all by itself. It's just more powerful and way less biased. I know, it sounds almost like magic, right? So you gotta ask the question, if this is so great, why isn't this tech on every single farm in the world already? Well, like with any powerful new tool, there's some pretty big challenges to work through. The biggest hurdle, and this is a big one, is data. Deep learning models are really, really hungry for data. They need tons of high-quality, labeled images to learn from. And the public data sets we have, well, they're pretty limited. The biggest one has 16,000 images, which sounds like a lot, but look at that smallest one, just 120 images. That's nothing for an AI. So that scarcity is a huge bottleneck. And it's not just about the amount of data. The models have to be tough enough to work out in a real field, with weird shadows and dirt and all sorts of other stuff in the background. They also have to be smart enough to tell the difference between a real disease and something that just looks like one, like a simple lack of nutrients. And on top of all that, this stuff takes a ton of computing power, which of course costs money. Okay, so those are the hurdles. But here's the thing. Despite all of that, the momentum here is just undeniable. Researchers are tackling these problems head-on, and the vision they have for the future of farming is, well, it's pretty incredible. A huge piece of that future is literally taking this tech to the skies. Just imagine drones or UAVs flying over massive rice paddies all on their own, snapping super high-res pictures. They can spot the very first signs of a disease outbreak from way up high, long before a person could, which means farmers can step in and fix the problem before it spreads. And another really key piece of this is something called edge computing. Basically, it means the AI model lives right on a farmer's phone or on their tractor, not on some server miles away. This is absolutely critical for places that don't have great internet. You get an instant diagnosis right there in the middle of the field, no connection needed. And finally, for any of this to actually work, farmers have to be able to trust it, right? That's where something called explainable AI comes in. The goal is to get rid of the black box, where you don't know why the AI made its decision. Instead, the AI will actually be able to show the farmer the exact spots on the leaf that led to its diagnosis. That transparency is everything for building confidence. So when you pull it all together, you realize this is about way more than just some cool new app. We're talking about using our most advanced technology to solve one of our oldest and most fundamental problems, making sure we can feed everyone on the planet safely and sustainably.
And that's really the thought I want to leave you with. We've just seen how deep learning can become a world-class expert on plant diseases. So if we can teach an AI to protect our food supply, what's the next huge global challenge we can train it to solve? I mean, the possibilities are just staggering to think about.